Hi, welcome back to Related Rates. This is example 2, and in this example we will look at one that involves, wait for it, geometry. Woo! Here's the problem statement. A conical tank with vertex down is 8 feet across and 10 feet deep. If the water is flowing into the tank at a rate of 8 cubic feet per second, find the rate of change of the depth of the water when the water is 4 feet deep. Period. Okay. Yeah, whoever knew that 2 sentences could cause so much trouble. Well, here we go. So, this is geometry because right away we're dealing with a conical tank, which is like a cone. Okay, so when we're drawing our picture, right, we have a conical tank. So you could do it like three-dimensionally like this if you want. I'm going to do it like this, like we're looking at it head-on. But just know that it is a cone. And there's our cone. Maybe it's like one of those paper cups, but it's giant because it's 8 feet across and 10 feet deep. Okay, so we know that it's 8 feet across, which means that the radius of this cone would be 4, because that's half of 8. And then the cone is 10 feet deep, so this height here is 10. And then the other thing we know about cones is we know the volume, the equation for volume. And usually this will be given to you in the problem. So V of a cone is 1/3 pi r squared times h. So that's dependent upon both the radius and the height of the cone, which kind of makes sense because it's the radius and the height. So things that we'll need to know eventually are stuff about the radius and the height of the water. So let's go ahead and like draw the water into the tank. So here's like, yeah, water coming in, got some water, yay, water. And it's filling up the cone to a height of about 4. No, why did I say 10? This is not, oh, it is 10 feet deep. Yeah, okay, so here's like the water, yay. And yeah. And the volume that we're talking about is the volume of the water. And so like the volume starts out low because it's down here, and as it fills up, as the cone fills up, that's our water changing, and then when it's at 4 is when we're like making our little analysis happening. So the water, we have variables associated with the water. The water has a radius and the water has a height. Okay, and so when we talk about this volume equation here, that's the height that we're using, and that's the radius that we're using as the radius and height of the water. Okay, cool. So now we can move on to the next sentence. So, if water is flowing into the tank at a rate of 8 cubic feet per second, that tells us the change of volume, because cubic feet is a volume, and so the rate of volume is V prime, and it's telling us that V prime is 8. That's basically what this is saying. And then it's saying that we need to find the rate of change of the depth. Okay, rate of change is our derivative, depth is h, so we're looking for what h prime, that was a bad prime, h prime is, and at some point we know that the water is 4 feet deep. Eventually we're going to plug in h equals 4. So if you look at this problem, right, we have a lot of like black information about the volume, and we have a lot of blue information about the height or the depth, but we have no information about the radius. Oh, that might be slightly ominous, but it's okay. And the reason it's going to be okay is like this. We don't know anything about r, and we don't know anything about r prime, and so the best way to deal with this is to get rid of r in this equation. Well, there's got to be a way to do that, so here's how we do it. We use something that you learned a long time ago called similar triangles. So I'm going to redraw our picture, right? Here's our big cone, like this, and the big cone has a radius of 4 and a height of, I believe it was 10, double checking, 10. 8 feet across, 10 feet deep, radius 4, height 10. And the water, here's our water, that has a radius of r and a height of h. And so if you notice here, like this thing is a giant triangle, and this thing, the water triangle, is similar. So here's another way to like see that horizontally. No, not horizontally, vertically. So you have RH, 4, and 10, and because this angle is the same, we don't actually care what it is, it's an angle. But so and these are both right angles, right? We have similar triangles. They're going to be proportional to each other through a scale factor, and that scale factor can be found by doing r divided by h. So the ratio of the radius to the height is 4 to 10. Cool. That can actually be simplified, and furthermore, we're going to solve for r. So we're going to say r is equal to 4/10, which is 2/5, times h. And this is wonderful because now we're going to take this and plug it into our volume equation first. So you're going to take v, which is 1/3 pi r squared h, and you're going to take that r equation that we just had that had h in it, 5/10, no, it wasn't 5/10, so what am I talking about? 2/5 h, and we're going to take this and we're going to plug it into r. And we haven't done any calculus yet. We've just done geometry and algebra and rearranging for a good reason, because if you notice, before we plug this in, if you notice this, right, you have r squared times h. And because we'll eventually have to take a derivative, if you leave it in this form, you would have to do the product rule. And sometimes you might. Like if you know stuff about r and r prime, then you would have to do the product rule. Since we don't, we're going to make it a lot nicer on ourselves and substitute in this 2/5 h quantity squared, and then do a little algebra to simplify this before we take the derivative. So, moving on. 1/3 pi 2/5 h squared is the same as 2 squared, 4, over 5 squared, 25, times h squared, which is, don't worry about it, h squared. Woo! And then h is h, and now we can simplify again, right? No derivatives yet. Actually, let's see, let's simplify our fractions. So we have 4 over 3 times 25. You don't even have to simplify that for, well, you'll see why in a second. Times h cubed. And now we have a nice place, this is a nice spot to be in, because now we can take our derivative, and if you notice, the only variable we have here is h, and all we would have to do is a power rule. So let's do that power rule. Nope, no, we'll just go to the next board. Okay, so this whole thing is constant, and it's a constant multiplier, so it's going to stay there. So v prime is 4 over 3 times 25 times pi, all constants being multiplied. And then here, that's our variable bit. We're going to power rule this, so 3h squared, and then, because it's related rates and it's a h and a variable, right, we got to do h prime. And remember, that's the thing we're looking for. If you don't have the h prime, then you can't even answer the question. So, yeah, here we go. And then, now we can plug stuff in. So from the problem statement, we remember that v prime is 8, so that's going to go here. 8 equals, and we can simplify this a little bit, so these 3's are going to cancel out because they're one's on top and one's on bottom. So we have 4 over 25 pi. H, well, let's find out what h is. It told us that, oh, now is when we do h is 4, because that's when it says when the depth of the water is 4. Now we're going to plug in h is 4 after the derivative. So we put a 4 right there, and then it's going to be squared. And then h prime, oh right, h prime is the thing we're solving for, because that's the only thing that's left that's not a number. Okay, so we can go ahead and solve for this. So I just rewrote it. So basically when we solve for h prime, we can just put everything on the other side. So the 25, when it goes to the other side, will become multiplied. So you'd have 8 times 25. And then everything else, this and this and this, would all end up being divided by on the other side. So it'd be 4 pi and 4 squared. And all of that will equal h prime. And technically, if it's, right, for your response, you don't have to simplify, you can just leave it. If it was multiple choice, we could do a little simplifying. For example, 8 over 4 is 2, 4 squared is 16, and then this 2 and the 16, we could make that 1 over 8. And so our final answer would be h prime equals 25 over 8 pi. And the units are important, so this would be feet cubed per second. And the way we do that is back in the problem statement, right? There it is. Cubic feet per second is feet cubed per second. Ta-da! Woo! You're done. Okay, so things to get from this are sometimes you have to use geometry to find an extra relationship between the variables, but other than that, the calculus is still, right, take the derivative, have the prime, keep on going.